Hello everyone. So in my last devlog session, I was working on this AST tree, and we provided support to parse those CXX method in a more convenient way. So providing all the details about the function, so a decorated name for the function or the method here, and then yeah, we remove the parsing of the children themselves. So that was a good step. And now, yeah, I'm thinking we have this class declaration, which is starting to look a bit nice. But in fact, I think that for CXX method and also constructors and destructors, and that we could also use the CXX access specifier. We can retrieve that directly from the cursor, and we can set that this function is public or private or something like that. So let's see if we can do that easily when passing method. This is only applicable to methods, because for free functions you don't have this this concept, I think. Yeah, probably not. So this is where this would happen, and we can just get the visibility of this cursor. I think that should work. So access should be cursor get CXX access specifier, and then maybe we could also add support to convert that to a string. So right in my cursor class here, retrieve the CXX access specifier, sorry, as a string. So we return a string. And that's not at all a semantic cursor parent. So cursor access and cursor access string. Sorry. So get CSX access specifier string. We'll start with the actual access value. So self get CXX access specifier. It should really be a valid cursor, so we can probably check that as valid. And oh no, I mean, yeah, it's not a cursor that we're returning, it's just a value actually. So no, there's no valid thing to check. It's an integer basically. So public will be 1, and then yeah, we have invalid, which is 0. Okay, so if, or we can prepare a small table for that. So local access names. So how do we do that? We have the 0 value. So I think we can just set 0. Or we can just specify that as invalid access. So protected is 2 and then private is 3. And we return the string corresponding to this access value. I think it should be converted to a string directly. Yeah, my Lua is a bit rusty on this point, so I'm not absolutely sure, but we'll see. So we have this additional helper function now, and we can use that when we are passing the method. So we can just get a string here. Access should not be invalid. And that's not really where we should check that. It's more in the base function here. Oh no. Yeah, that's a problem when you have the Lua language server activated. Sometimes if you have an error like that in the code and you try to save the file, it's confused and it's deleting everything in your file, or almost everything. So that's a bit of a pain. Maybe I should consider an update. Okay, so say we get the access as a string here, and so yeah, probably want to pass that to the decoration function here. How should I do that? I mean, the decoration function can do it itself, since we're reading that directly from the cursor, in which case we can in fact accept invalid access specifier. So if I would rather go here, yes, that's the one. And you would do access equal, but only if your cursor kind is a CXX method or constructor or destructor. So you have 3 cases already. Could we have private function in a class or something? I don't think so. So what should I do? I guess, yeah, we don't really want to check that. And it's just that for 0, we should not provide anything, so we'll return nil. Or we can provide yeah, string or nil. So here we have a string or nil. So we'll do that, and for the prefix part, so if access then prefix equal space and the prefix. Good. So with that, I would expect all those methods here to be updated, and we should have a public keyword. Or should I put the attribute before? Yes, I think that could be a better option. Yo, well. Not quite producing what I was expecting. Okay, what does it mean? Access specifier is invalid for, let's just use the row name. Not here, of course. It really doesn't want to type the access specifier. That's a shame. But we should have a lot of those entries then in the log file. Yeah, quite a lot indeed. So what does it mean? It means that this option here will not work at all. We need to do what we were doing before, which is to progressively keep track of what is the current access specifier. So when you start the class parsing, by default should be, I think it's protected? I don't remember. And then the first time you find something, you should change that to, I don't know, maybe public or something. Then you use that for everything under until you find another one which would change that to private, and then you start using that for the next entries and so on. Yeah, it's a bit of a pain. That could mean that in fact we can only call that on a CXX access specifier node. So when we have this node, we can get the value from it. Could that make sense? Is this what I'm doing actually in the existing code? Let's check. declaration. Not quite. Get type declaration, get the declaration, and then from that I was trying to get the access specifier. Oh, yeah, I mean, yeah, I'm a bit stupid, sorry. Here, yeah, we can get the access specifier from a cursor, but when we do the parsing of, no, I'm not that stupid, actually. When we do the parsing of a function, the cursor here is for the function itself. So no, that should work. Come on. I need to think about that. Oh, okay, I could clarify that in the end. The problem was in the function that I created here to get the name of the access specifier. I was using strings here, but in fact, yes, that's a bit of a confusing point because in Lua, actually, your key can be anything. So there's no automatic conversion into strings. So when we provide an integer here, it's going to search for an integer. So wasn't finding anything and returning nil. Now that this is fixed, we actually get some proper results. So in the class declaration for the constructor here, we have this private. Then we have another access specifier here changing this current state. Then we have the constructor where we get the public, and then we have fields. I guess for fields also we could use the access specifier. And right now what this means is we can just bypass reading those because we can retrieve that for any other node afterwards. So just some cleaning first. This is not needed. And here, if you think about it, since this is a simple Lua array, I should be able to just list the different value I want. And we'll be using the key 1, 2, and 3 anyway. Just make sure that I'm not breaking this. And there was another thing I needed to change. Let's check that. We'll still have public, private, so that's good. But then, where is it? Here, yes. Sometime we may still have no access at all if you are considering, for instance, a regular function or function template that is not part of the class. So this warning will still happen a lot of time, in fact. So if we try to search for that, we'll get that. many times. Oops, sorry. Yep. So if we get that many times, that's probably not a good thing. To keep it here, we can just remove it. It's not really a warning at all. But when we have a valid access, we apply that. Good. So next. Yeah, let's first commit those changes. Next, as we said, we could ignore those cursor and do not even display them. When we are in a class declaration, at least, because when we are not in a class declaration, not quite sure what we should do with that class declaration or class template, in fact. So let's maybe consider the class template, because that one is still a bit messy and should be cleaned up. So in this one we can have template type parameters. Let's have a look at the main function. The get full name here. What do? I think we have a dedicated section already for class template, but the current implementation is not good, actually. That's relying on the fact that the class should already be, the class template object should already be defined on our side, which is, well, not the case when we're just passing the AST and nothing is actually processed yet in the NervLand framework. So we can't really rely on this to access, so this part should really go away. But then what should we do? We'll go with the same path. Actually, let's just get the full name for this class template with a dedicated function. Starting with the row name. So get class template full name. So this part we should not need anymore. Yes, I keep adding those big functions here, so this file is becoming too big. I really need to cut this into small pieces, so we have to handle this also. Class template full name. Good. What should we do? Parameters, do we have parameters for that? Not really, but we have template parameters. So TPL names. Parameters doesn't really make sense. Attributes could be, I'm not sure. And this is a list of things that we want to ignore. For now, the list should be empty. So maybe we should just put that after a first statement like this one. If we have a param declaration, I mean, no, we're not going to have a param declaration either. So this should be discarded too. If we have an attribute, maybe, then yeah, maybe this is one we can add to the list of attributes. And then we have the case where we get a lot of other stuff, but we don't quite know what to do with them. But for now, let's not handle any of these. Okay, no param, but it's not even a function here, so I don't think I should go in this function. I should probably just stay here, and for the moment just return the row name that I'm provided as an input, and if we have template parameters, then we should display them. So we need to concatenate that. That would be the suffix actually. Suffix is going to be, we have this angle bracket opening, then table concat. We take all the template names and we separate them with commas. And finally, the closing angle bracket. That's a suffix that we will add here at the end of the class name. Okay, and on the class template child. Good, we don't really need the kind, but eventually we'll have to use it, so let's keep it. Let's keep all of this. Okay, and now we are already using that right just here. In fact, even before we try anything here, I'm going to restore this code, comment this part, ensure this is working. No error, that's good. And I need to find a way to put those big methods somewhere else. What are we going to do exactly? We're going to go into clang, and let's create another folder for that, details. And what do we do? Create a new full name helpers or something like that. Or we can just do, yeah, maybe clang detail full name. On Lua, okay, and this one is going to get or create the clang namespace. Just in case, and then we'll add those functions right in it. So where do we start? We have the new one we just added here, then the cxx method, then the function declaration function, full name, sorry, and then function template full name. I think we need, come on, I was pressing shift. We take those four, Control X, removing them. Oh, this one could also go there, but and then we paste that here and we'll call that, it's not local anymore, we'll put that in clang, or maybe clang utils. Yeah. Which make me think that we could probably call this folder utils too. And this function here is missing, so we can provide that. Like this, and rename this folder to be utils. Then in the cursor at the very beginning we can import this. Full name. And then all those functions are missing, but we can just call utils to get them. Okay, good. Should still work exactly the same. And it's not working. Okay, that's from the util part. No, the full name, yes, that's correct, because I mean, this can be local, in fact, so let's just keep it local for now. Okay. Good. 2 seconds. My, that's fast. So what did we do? We separated our helper function for full name resolution into a dedicated file. So added now back to the usage of the get class template full name here. Again, this will be in clang utils. But we need to comment all the following statements. And now this should produce something. Where is this? Yes, that's it. Okay. This should produce, yeah, a class template name with the template parameters. Oh, no template parameters because we're not collecting them yet. Let's see. Actually, it should maybe just produce, yeah, throw an error because we're not collecting anything. And we have those template type parameters, for instance. So, do we get this somewhere for, yeah, in the function template, we have that. So we probably need those 2 lines. So if it's an attribute, we do something. So if we have a template type parameter, we add that to the, we just get the name actually, used for that template type, and we add that to the list of template names. Same for the non-type template parameters. And that's it. But we'll have a lot of additional errors here because of missing processing. Enum declaration. Yes, of course, you can have enumeration in a class template, but that doesn't really well participate in how you build a full name for that template. So it should be safe to just ignore that. I mean, there will be a lot of things to ignore here. So let me enter all those errors and get back afterwards. Okay, so I have now listed all those elements that are available as direct children in the class template. Actually, all of this are, well, all of this, a lot of those elements are pretty important and we'll need to pass them somehow. So we can't really stop the visiting process at the level of the class template, of course, so we need to go deeper and revisit those children. But to figure out what is the proper full name for the class template, then yeah, you don't really need them, so you can ignore this for the moment. While I'm at it, I'm also going to remove those. And so now we have a lot less debug output when we run the processing here. You see it's much faster because oh, that's an interesting one, because most of the remaining output were from the function that we used before and this warning that we were displaying. So we don't have that. Now let's see what the class template full name will look like. So here's a last example. Another one here, taking this as a parameter. Okay. Oh, no, that's a partial specialization. That's something else. Okay, here we have two parameters. One which is a bool, a non-type, and then another one which is a type. Okay, I'm in bool and type. Is same, okay. Remove counts, okay. Okay, so that seems pretty good so far. Wait a sec. Disjunction. Oh, that's interesting. So we might have to consider parsing some of those statements at some point. That's, yeah, going to be interesting. Anyway, so we have the class template parsing in place here. What is this doing exactly? In fact, it's just retrieving the template type and non-type parameters. Children. I mean, retrieving the children node, those kind, to just append them to build the full name of the class. Why not? Okay. So back to how we proceed here with the naming. Can we move that properly? We don't really need to rely on the class template anymore. I mean, before I start deleting stuff, there's something I need to check. First, I need to commit those changes. So, updated full name computation for class template. And before I actually send that, there is this additional step. I need to check that I'm not breaking everything in my binding generation system, which would be bad. Yeah, this is taking a little bit of time because there's a lot of stuff to bind here. Okay, so binding generation is done in about 50 seconds, and actually there's no file updated, which means that all the bindings were generated exactly the same as before. So we didn't break anything so far. That's good. So we can commit those changes on the class template full name retrieval. And we can also clean up a little bit. It's part of the code here. Okay. And what's next? We had this inferred full name cursor. I think we had that at least once here. Using directive. Okay, maybe we should do something for using directive. Can we put that here? I don't know. Get kind spelling, full name. What are we producing? STD chrono. That's the parent part of the name, and then the spelling using directive. I mean, using probably something you should not display. Okay, we have only one of it. And it's going to be in the namespace chrono std literals. So yeah, in a namespace we might be using other types, so that's where you would see something like using another namespace or something like that. I think this can be just, yeah, bypassed. So in the full name, when we have using, where should we put this? It's namespace ref. I really don't know what to do with it. Using directive, and we should return just nothing that meaningful. Okay. Okay. Next thing I should do, what is it? Next thing I'm thinking about now is well, when we have class declaration like that, I would like to make it look a bit better. So class declaration, I mean, for instance, for the class template, we are already, yeah, accessing this cursor and iterating on the children to generate the proper name, because we need to find those template type parameters. But I'm thinking maybe we should also delegate the display of the additional lines to this function here to decide how to print the constructor and stuff like that, maybe. That sounds a bit tricky for just the display part. Maybe it's not absolutely necessary to do it. Okay, so let's not do that. For now, I think, yeah, this is a good session already, so I stop here, and next time I'll find something else to investigate anyway, and we'll continue from that point. Bye-bye.